Greetings, fellow explorers of the cosmos and our future. I'm Mohammed Sa. Today, we embark on a journey through innovations remaking our world. Artificial intelligence now diagnoses disease, quantum computing tackles the unsolvable, and carbon capture helps heal our planet. Brain-computer interfaces restore senses and movement. Self-healing materials promise a future of durability. These are paradigm shifts, born from relentless curiosity. Each breakthrough builds on the last, creating a symphony of progress. Imagine a physician with the knowledge of every medical text, able to spot patterns invisible to the human eye. This is the promise of AI-powered healthcare diagnostics. AI systems now detect diseases like cancer and heart conditions earlier and more precisely than ever. These tools bring high-level diagnostics to remote areas, making quality care less dependent on location. The goal isn't to replace the human touch, but to empower it, making healthcare more accessible and accurate. Enter the world of quantum computing, where classical rules dissolve and qubits, capable of superposition and entanglement, unlock vast computational power. Recent breakthroughs have brought us closer to stable, scalable quantum processors, with researchers exploring superconducting circuits, trapped ions, and more. Quantum algorithms and error correction are advancing, inching us toward fault-tolerant machines. The challenges are immense, maintaining coherence, extreme operating conditions, and manufacturing precision. Yet the potential is staggering, designing new drugs, optimizing logistics, revolutionizing cryptography, and even advancing AI. Quantum computers could help us understand the universe's deepest mysteries. We are truly at the dawn of a new computational age. Our planet faces an existential challenge: rising greenhouse gases and climate change. Carbon capture, utilization, and storage, CCUS, intercepts CO2 at its source or pulls it from the air, preventing further warming. Methods include point-source capture at factories and direct air capture with giant fans and filters. Captured CO2 can be turned into products or stored deep underground for millennia. CCUS is vital for decarbonizing industry and achieving negative emissions, but it's no silver bullet. Cost, energy use, and public acceptance are major hurdles. Success demands innovation, supportive policies, and global cooperation. CCUS is a crucial piece of the climate solution puzzle. Brain-computer interfaces, or BCIs, unlock the brain's mysteries by linking neural activity with technology. They restore movement, communication, and may one day bring back lost senses. BCIs could also enhance memory, learning, and creativity. As BCIs advance, we must address ethical questions about privacy and access. Nature's resilience inspires self-healing materials, engineered substances that repair themselves without intervention. Imagine a phone screen that fixes its own cracks or concrete that heals itself, reducing waste and extending lifespans. Techniques include microcapsules with healing agents, vascular networks, and shape memory polymers. Applications span aerospace, construction, electronics, and textiles, promising a more sustainable material economy. Challenges include cost, durability, healing speed, and scalability. Ensuring environmental safety and recyclability is essential. The goal: materials that are not just smart, but wise throughout their life cycle. Picture a factory running 24/7, fully automated and nearly human-free, the lights-out factory. Advanced robotics, AI, and digital twins create self-regulating, adaptive production systems. These factories boost productivity, cut costs, and enable mass customization, but raise concerns about job displacement. Workforce reskilling and new roles in automation management are essential. High upfront costs and cybersecurity risks challenge adoption, especially for smaller firms. Managing these complex systems requires new expertise. As we build these factories, we must ensure the benefits are shared and human ingenuity remains central. For decades, AI has excelled at narrow tasks, but the holy grail is artificial general intelligence, AGI, machines with human-level cognitive abilities. Recent advances in language models hint at AGI's potential, but true understanding and generalization remain elusive. AGI could revolutionize science, education, healthcare, and creativity, acting as a true intellectual partner. Yet it raises profound ethical questions: alignment with human values, job displacement, and the rights of intelligent machines. The control problem, ensuring AGI acts in humanity's best interest, is paramount. Developing AGI is as much a societal and philosophical challenge as a technical one. Navigating this future demands global collaboration and foresight. Our energy future must be sustainable, shifting from fossil fuels to decentralized, intelligent, renewable grids. Smart grids enable two-way energy flow, letting consumers become producers and optimizing supply with AI. Integrating renewables like solar and wind requires robust storage, batteries, pumped hydro, green hydrogen, and modernized transmission. The transition faces technical, financial, and regulatory hurdles, plus the need for public engagement. Ensuring equitable access to clean energy and supporting affected workers is critical. The journey to a sustainable grid is a marathon, demanding commitment and collaboration. The stakes, the well-being of generations, and the planet itself. Robotics is evolving from caged industrial arms to intelligent, collaborative machines working alongside humans. Soft and bio-inspired robots, swarm robotics, and advanced AI are expanding robots' roles in healthcare, logistics, agriculture, and hazardous environments. Domestic robots are emerging to assist with daily life, promising greater quality of living. Achieving human-level dexterity and adaptability remains a challenge. Safety, reliability, and ethical concerns, like job displacement and data privacy, must be addressed. Proactive workforce adaptation and thoughtful integration are essential. As robots become partners, we must ensure they serve humanity's best interests. Advanced biomanufacturing uses cells and enzymes to produce medicines, fuels, materials, and food, growing products with biological precision. Synthetic biology, gene editing, and AI are enabling custom-designed organisms and efficient bioprocesses. Applications include biopharmaceuticals, biofuels, cultured meat, and self-assembling biomaterials. Scaling up production, reducing costs, and navigating regulations are key challenges. Public acceptance, especially for GMOs and cultured foods, is crucial. Continued innovation and ethical frameworks will ensure biomanufacturing benefits all. This is a paradigm shift towards sustainable, life-powered production. The technologies we've explored are interconnected, amplifying each other's impact. AI refines healthcare and powers robots. Quantum computing could revolutionize materials and climate solutions. We are not just witnessing change, we are building the future, idea by idea. These innovations offer solutions to global challenges, but also bring new complexities and responsibilities. The future is shaped by our choices, investments, and collective wisdom. Stay curious, engaged, and imagine how you can help shape a future that is advanced, equitable, and humane. Thank you for joining me on this voyage.